The double dividend is the final chapter on the cost of greenhouse gas emission reduction. There are many claims that we could reduce emissions and save money at the same time, a win-win situation, but unfortunately most of this is bogus. The first common mistake is a confusion of market forces and policy. We've seen this graph, and we've seen that over this 50-year period, energy intensity has fallen steadily. And this is not because of policy interventions, this is because of market forces. Energy is a cost, and it is in our own interest to save on that cost. But nonetheless, some people believe that without their intervention, technology would be frozen. And if that were the case, then indeed improving energy intensity would save emissions. But it is just confusion. One of the confused people is George W. Bush, Bush the Younger, who at one point announced that his major contribution to climate policy was that the energy efficiency in the US economy would improve by 14% over the next decade. And he completely forgotten that announcement. In the preceding decades, energy efficiency had improved on average by 18% per decade. A second common mistake behind claims of negative abatement costs, a common mistake that you often find in engineering models, is the inappropriate use of discount rates, or rather the use of inappropriate discount rates. Why is the discount rate important? Well, a lot of emission reduction is really an investment. When you put insulation in your walls, you have a capital outlay, but then you start earning money back because your heating costs are lower. If you replace your heating system with a more efficient one, you have an initial capital cost, but you earn back money through lower heating costs again. And therefore, the question whether or not this investment is a good idea depends on your discount rate, and how important is future money relative to today's money. Now, for some reason, a lot of engineers seem to think that households and companies can borrow money at the same rate as the government can. It's unclear how they got this idea, but that is what a lot of engineers seem to believe. Apparently, they've never been in a bank, they've never tried to get a mortgage, and never realized that a bank charges them a lot more than they would charge the government. And that makes these capital outlays a lot more attractive, even though they really aren't. The third reason why engineering models go wrong on this and incorrectly claim that you can reduce emissions and save money at the same time is the omission of hidden costs. Typically what goes into these models are the capital outlay and the energy expenditure, but there's no such thing as repair. But if you are the first person to buy a Tesla, an electric vehicle, you save emissions, that is very true, but if it breaks down and you want to get it repaired, you can't take your fancy new car to your garage around the corner, because they would not know how to fix such a car. And that means that you would have to go for a long time without a functioning car until an engineer is flown in this case from California, to fix your car. And that is a cost, that is a real cost, but it's often not counted. And definitely if we are talking about new and innovative things, the state-of-the-art technology, and the state-of-the-art technology does do a lot of good for the environment, the state-of-the-art technology also comes with very specialist knowledge, and reparations, for instance, are simply expensive and difficult. If we start including these sort of elements into the cost-benefit analysis, then those emission reductions all of a sudden seem a lot less attractive. So most of these claims that you can reduce emissions and save money at the same time are simply wrong. There is, however, reason to believe that there could be such a thing. And in order to understand that, we need to go back to the models that we talked about a little while ago. And the model results that I showed before are from two types of models. They're either optimization models, models that minimize the cost of the energy system, or their equilibrium models, computable general equilibrium models, for instance, and they assume perfect markets. And therefore they are in a market equilibrium that is a Pareto optimum. Now, if you're in an optimum, then anything you would do, any policy that you would introduce, would necessarily increase costs. If you're at the top of the hill, the only way is down. Now, if on the other hand your starting point is not some sort of optimum, but if your starting point is an imperfect market, then the cost may be positive or negative. If you're somewhere on the side of the hill, depending on what direction you travel, you can go up or you can go down. At the top of the hill you can only go down, at the bottom of the hill you can only go up, but at the side of the hill you can go either up or down. And markets are imperfect, and the question is, could we use climate policy to reduce the overall market failure, to reduce the imperfections in the market? And if we could, then we would at the very least offset some of the cost of greenhouse gas emission reduction, and we may even flip its sign. There is a lot of work on this in public economics, and there's basically three rules that matters. A tax is said to be more distortionary if the tax base is narrower. Now, what do we mean by distortionary, or the distortionarity of a tax? The starting point is an economy without taxation. Now, if you introduce taxes, then essentially you change the behavior of people, because if it's an income tax, you reduce their income and therefore consumption patterns, and as well as labor supply and those sort of things. Or if you use a value-added tax, you change the consumption. And definitely if it's a differentiated value-added tax, as most value-added taxes are, or an excise that is necessarily differentiated, then you get people to buy different things than they otherwise would have bought if there were no taxes whatsoever. The starting point is an economy without taxes, and then you have an economy with taxes, and then the distance from the consumption bundle of what people would have bought in case there were no taxes to the consumption bundle that they did buy when there are taxes, that distance is the distortionarity of the tax. Now, tax is more distortionary if the tax base is narrower. What does that mean? If the tax base is narrower, fewer people pay the tax. So for every £1,000,000 raised, fewer people pay that tax, and therefore they get a stronger tax signal, and therefore they change their behavior more, right? So a tax is more distortionary if the tax base is narrower. A tax is also more distortionary if the price elasticity is higher. And that is simpler because for any £1,000,000 of tax raised, you send a certain tax signal. If people respond more strongly to that, the price elasticity is higher, then they change their behavior more from the situation without the tax. So tax is more distortionary if the tax base is narrower, or if the price elasticity is higher. Now, the deadweight loss, the difference in welfare with and without the tax of a tax, is roughly quadratic in the level of the tax. That is just a rule of thumb that comes out of many economic models. Now, what does that imply for our situation? If we impose a carbon tax, we distort the economy, we impose a welfare loss, but not by that much. And the reason for this is that the tax base is broad of a carbon tax because everybody uses energy, everybody eats food, so the tax base is broad. Essentially, everybody pays the tax. And the price elasticity of energy and food is actually quite low because these are basic necessities. So the distortionarity of a carbon tax is not that high. So that is a good thing. And of course, the starting point is a zero carbon tax. So if the costs, the debt-based loss is quadratic and the base point is 0, then we're actually not that we're not that bad off. But if we raise a carbon tax, then the government has tax revenue, and it could use that tax revenue to reduce other taxes. And if those other taxes are more distortionary than the carbon tax, then we have reduced the overall distortionality of the fiscal system, and we have a welfare gain. And that would offset at least part of the costs of greenhouse gas emission reduction. This is known as the revenue recycling effect. What you could do with the tax revenue is reduce the labor tax. That is a pretty distortionary tax. The tax base is narrow because only those who work pay the tax, and that immediately excludes about half of the population. Price elasticity is also very low, actually. Now, if we do so, if we reduce the labor tax and reduce the overall distortionality, we also increase labor demand, because the labor tax makes labor more expensive and therefore suppresses the demand for labor. We reduce the labor tax, labor demand goes up, and therefore unemployment goes down. It also increases the labor supply because for the same work, your take-home pay goes up if the tax goes down. So people would be more inclined to work. So if this is what we do, if we shift the taxation from labor to energy, the revenue recycling effect is positive. And this is known as the second dividend. So this is the double dividend that I was talking about. And of course, the first dividend is that we reduced emissions. And now there is a third thing going on here. And that is that a carbon tax means more expensive energy, by definition. That means that inflation goes up, prices go up, and that reduces the real income. And that, of course, means that the supply of labor falls because labor is less rewarded. This is known as the tax interaction effect. Essentially, the carbon tax makes the labor tax worse. In certain theoretical models, this tax interaction effect is always larger than the revenue recycling effect, but that is under some pretty stringent assumptions. There's also been a lot of work where people build to their best ability models of the economy, and here are some results. This is somewhat older work. It's kind of a little bit out of fashion, but it doesn't make any less important. What you're looking here at the vertical axis is the change in welfare, Higgs equivalent variation. On the horizontal axis, you're looking at emission reductions, starting no climate policy and all the way up to 30%. And then we have three alternative measures of welfare, Higgs equivalent variation, consumption, and gross domestic product. And positive numbers means that things have gotten better. Negative numbers mean that things have gotten worse, and then the different dots or crosses they are different countries. And what you see is that by and large, in this particular model at least, welfare has gone up despite the emission reduction. We reduce emissions and get better off at the same time. This is from the same study, and here we're looking at variations in the way the labor market is modeled, because most of the revenue recycling is from a reduction in the labor taxes. So what you think about the labor market is actually important. And yes, it matters. And actually, the more realistic labor markets see a stronger effect than your classic micro 101 labor market. And this is true throughout Western Europe, according to this particular model. What you're looking at here is more results from the same study. Again, positive means that you're getting better off, and negative means that you're getting worse off. And here the question is, what do we do with the money? And here you see a whole bunch of results for Germany, for instance. And depending on whether you use the money to reduce public debt, or whether you send everybody a check in the post, or whether you use the money for investment recycling or capital tax reduction or VAT reduction, you get different results. So it matters quite a lot how the money is used. And that is also seen in these results here. So here we have 4 different models of the US economy. This is again an older study. As I said, this has gone out of fashion, but it isn't any less important. The scenario that is modeled here, and was actually done in the mid-1990s, what would happen in 2010, which was then far into the future, if we impose a $40 per ton of carbon tax. But that is irrelevant. That is in the future. That this is in the past now. So we have 4 different models, and we have 8 different ways of spending the carbon tax revenue. If the money is returned lump sum, then all the results are negative. That is, there is a welfare loss across the board. Now, what is a lump sum tax recycling? Essentially, all households are sent a check in the post. And that may seem strange to our European ears, but that is occasionally what the US government does. It sends everybody a check. But this is a bad idea. This is a bad way of spending the carbon tax revenue. Government consumption can increase. That's also a bad idea. Personal income taxes can be dropped, corporate, and that is a bad idea. But what could also be done is that corporate income taxes could be reduced, profit taxes, and that is a good idea according to 2 models and a bad idea according to 2 other models. Now, why is this different from the results that I previously showed you? In Europe, when you reduce the personal income tax, welfare goes up. And that is the result that I showed here. In the US, welfare goes down. But if you reduce profit taxes, then welfare goes up. The reason for this is simple. In the US, companies are taxed heavily and households are taxed lightly. In Europe, companies are taxed lightly and households are taxed heavily. And therefore, the most distortionary tax in the US is your profit taxes, and the most distortionary tax in Europe is your labor taxes. Why there is this variation in between Europe and the US, I don't know. It may be because in the US people vote, and in Europe companies vote. Maybe that is the reason. I don't know. But it is the way it is. And then they tried a couple of other scenarios, and actually. Now it matters that this study was done in the early 90s. If you increase the investment credit, the tax treatment of investment, then you actually see the largest increases in GDP. And the reason for that is that at this time the US suffered from a dearth of investment. There simply was not enough savings to go around, and there was not enough investment in the US economy. Now, what does this tell us? Well, a couple of things. First is, yes, these tax recycling effects are real and they are positive, and it really matters how you spend your carbon tax revenue. That makes a real big difference to the overall outcome. But in order to spend this money wisely, what you need to know is how does your economy work, and particularly how does your current system of taxes and benefits affect that economy. So you need to be a pretty smart economist. And you also, as a politician, need to be able to tell, well, is DRI the better model or is Link the better model? or perhaps we should trust Google, or is it DGEM that we should really trust? So this is actually a very tricky question. So as a politician, you need to fully understand your economy and your fiscal system. And that is a pretty tall order. Most politicians are not trained economists, and as you can see, trained economists actually disagree on these matters as well. And the next thing you need to do is that as a politician, you need to be able to resist the temptation, because you get a lot of money as carbon tax revenue, and you could use that money instead of doing what is best for the economy. You could do what is best for the people who vote for you, or the people who lobby you hardest, or if you're the current president, what is best for your own family. So as a politician, you also need to resist the temptation. For these reasons, my takeaway message is that yes, this double dividend exists in theory, and it could exist in practice, but it needs to meet some pretty tall conditions. You need to have politicians who actually understand what they're doing, and you need to have politicians who actually want to do the best for your country. And for those reasons, I do not put a lot of stock